So graphing, I think, is super important. So I'm going to sketch this out right here. Let's do that up here. That should work fine. So standard form for hyperbola, we want to end up with that equation, and we have vertices. So those are points they pass through as opposed to the focus, which are related to distances of points. So 3. So 1, 2, 3. We have 1 here. And 1, 2, 3, we have 1 here. So those are actual points on the graph at 3, -3, here and here. And then we're given one of the asymptotes. So the other asymptote is just going to have to be the opposite of that if they pass through the origin. And since this doesn't have a y-intercept, it has to pass through the origin. So 1/2, -1/2 x would be the other one. So my asymptotes would be up 1, right 2. So let's go out a little. Let's say, oops, I lost track. Up 1, 2, let's start here. So there's one asymptote, oops, right there. And the other one about here. And so the curve I want has to pass through that point, oops, through that point, and then curve toward, but behave asymptotically toward each of these lines here. Same on the other side. So here's a rough graph of the hyperbola that I'm looking for there. So other thing we know about a hyperbola is that if I, from this vertex, let's use blue, if I draw a line up to its asymptotes and down to the asymptote on each side, the box that I form here tells me what B is. So then this, whatever that value is right there, that has to be my B here. And since I know the slope here, I can pretty easily figure out that. So I know the slope is 1/2, right? Over 1, up 1. And I know that I'm going right 3. How far do I go up to stay on that line? So rise over 1, I know if I go right 3, how far do I go up to stay on that line? So pretty straightforward proportion with a slope here. To solve for question mark, we just multiply 3 on the other side. So I get 3/2 is equal to question mark. And that question mark right there is my B. So B has to be 1.5, and that looks reasonable in my sketch here. And I did graph these lines accurately, even though my hyperbola may not be accurate. So call it 3/2 or 1.5 if you wish. I'm going to call it 1.5 now because that's a nice decimal. And since this is oriented horizontally, it's got to be x squared over a squared minus y squared over b squared equals 1. And I'm just going to double check on a graph that that looks correct. So let's get a new version of Desmos up. And things I know for sure, I'm just going to plot one of the points. I know I should have the point 3, 0. And I know one of my asymptotes is y equals 1/2 x. And there's the asymptote. And based on that information in my sketch, using the slope, I believe that the equation should be x squared over 3 squared minus y squared over 1.5 squared, and that has to equal 1. And what I'm looking to see is, does that equation pass through one of my vertices? And it looks like it does there. And then does it appear that that hyperbola has the right asymptotes? And that looks pretty asymptotic as I zoom out there, right? To double check that that's the asymptote is always the ratio of B to A. And so if I take my b, 1.5, and I divide by 3, which is basically what I was setting up right here, 1.5 divided by 3, well, 3 is twice 1.5. So yeah, that's still in the ratio of 1 to 2, which is the slope of the asymptote. So I did come up with the correct equation.